So recording has started. So once again, good morning, everyone. Thank you for joining for another session of Azure Power Lunch. This session is being recorded and we place our recordings on our YouTube channel. If you are not comfortable with it, you may want to drop off now. So with that, we are today going to talk about confidential computing on Azure. Um, Security is a big topic of interest, and this is um, very much related to security, privacy, and compliance. Um, so, with that, here's a quick agenda. We're going to talk about confidential computing, why we need it, what gaps it fills, or what needs it addresses, and then we're going to talk about what are some of the Azure Confidential Compute offerings. There will be a little bit of a demo and Q&A. The thing is, this topic is huge. So probably we will cover this is kind of a high level session with a little bit of a demo, and then we will cover like what are some of the offerings, and we go deep into it in a future session. So that's the goal. Hopefully you find it useful. Okay, please feel free to ask questions. So it starts all with data protection. You know, customers, with the hackers and bad guys being very sophisticated, customers need protection. And the way we protect is we have data at rest. So let's say sitting in a database or a storage account, you have encryption at rest to protect that data. So that addresses that need. When data is stored, it's protected. When data is moving between systems, the way you protect is encryption in motion. You know, TLS, some of these example, HTTPS are some of these example of data protection in motion. But what about when the data is in use? So think of a scenario where you have um, confidential data, and I'm gonna go a little bit more kind of detail. Let's say that you have customers' um, social security numbers, you have their health information in a system. It is protected there through encryption, all that. But now you need to process that. You need to do some kind of analysis on it or whatever. There's a program that's going to run, and you're going to load it. And let's say that's running in a virtual machine. You're going to load it in a VM and run that. Okay. What is the protection there? When we talk about protection for data in use, what's the protection when the VM is running, somebody physically access it, take a memory dump, or let's say that the VM is running in a cloud. There's a 0-day hypervisor, but somebody gets in uh, through a hack or through a vulnerability and able try to get a memory dump of the process to get these IDs and make use those in a bad way. So how you address that? That's where confidential computing comes into picture, and that's the protection for data in use. That's the use case that it is addressing. Okay. Um, so as we move forward, what are some of the threats? As I talked about, you have the privileged admin who may be malicious. They somehow get access, and now they're trying to um, kind of use this access to get into this, access to confidential data. There may be vulnerability or bugs, and then there may be third parties who are want to access that data in unauthorized fashion. So these are the scenarios that this confidential computing is there to address. So this is kind of a high level picture. This to cover the kind of a what some people call like a three-legged stool. You have data and protection for data at rest, protection for data in motion, and protection for data in use through confidential computing. So that's what we are trying to address. So this is kind of at a high level, and that's where you have the trusted execution environments that comes into picture when we are talking about protection of data in use. And we will discuss it. And So now let's go into confidential computing. Confidential computing is a term that is kind of coined by this Confidential Computing Consortium, CCC, and that Microsoft is a premier member of it. There are other members, large tech companies. They have kind of they have sat down together to resolve the issue of how to protect customers um, when they have their data in use. And the protection is provided through a trusted execution environment, which is hardware based. And the goal of this environment is to make sure that there's no unauthorized access to when the code is running. Think of it that another metaphor. Let's say you are having a confidential meeting. Let's say it's kind of a big, high level meeting between, like um, very top secret agencies. First of all, they will not have this meeting at a Starbucks or something. It will be in a room which is confidential. Okay. They will make sure that there are no bugs in this room, nobody's recording there, unauthorized way, things like that. So, first, you have to have a secure environment to have the meeting. But at the same time, you have to have somebody at the entrances to make sure everybody who is getting in, you know, is authorized. It's not like somebody comes in and he just gets in. I mean, you may have a secure room, but now some bad guy comes in and he's sitting and listening to your conversation. That's does not make it a secure meeting. you know so I hope you get the point. So that's the trusted execution environment. That's what it does. So what it needs is, first of all, it needs to be able to make sure that your execution environment is the one that uh, secure, and then or where you are, that's a secure enclave. And the second thing, it makes sure that nobody can access unauthorized way access that information. Okay, so that's the goal of confidential computing. Any questions so far? Okay, so this is kind of a trusted execution environment, and one of example is Intel SGX processor. So that's what it provides, where I mean you have uh, the way you create it, you know, the code or data cannot be modified from outside. That's the goal of this environment, kind of a seal to make sure. And it also supports attestation, because first of all, let's say that you run your code. Before you can run it, you want to make sure that this is a secure environment. Just like I was talking about the metaphor for a secure meeting, the room is secure. So how you test it out? There is an attestation service where you send the information by talking directly to the virtual TPM. Hey, this is my information, and please check if this is a secure environment. If you get the response back, then yes, that's a secure environment, and you can move on. Okay, so that's kind of there's no snooping, all that. So, okay, so now move on to the Azure Confidential Computing. So, we talked about confidential computing. Azure Confidential Compute is basically a set of offerings that allow customers to run their workload where they need to take advantage of confidential computing in Azure. And there are different ways you can run it. There are different PaaS services, as well as IaaS services, which provide this capability. And this is kind of a summary of that. Okay, so this is some of the key foundation. Okay, um, for example, it starts with um, hardware root of trust. Um, Basically, Microsoft operators cannot modify hardware configuration. So that starts at the core. Second part is I talked about the attestation service. So Microsoft provides an attestation service where you can make sure that the room is secure before you can conduct your meeting. Okay, and then this is the trusted launch. That's also an interesting thing where you have a secure boot. So first of all, so what you can do is, I mean, that can detect while you are launching, the software with the customer software. It makes sure that you are in a trusted environment, and so it can take advantage of the attestation service to check if there is anything wrong with the system, everything is good. And then there are other features like memory isolation and encryption to make sure that any uh, sensitive data is that and properly isolated and all. So I mean these are some of the key offerings that Microsoft provide, and then you have these services. So I'm going to talk about so there are certain virtual machines that you can use. There's EC series, DC, DCA, DCD. All of these machines use processors that that underlying take advantage of the underlying hardware to provide you these confidential computing capabilities. Okay. Any questions? I mean, I know this topic seems sometimes like, okay, this is, too much uh, information. Like, okay, wow, packed it into very little time. But trust me, I mean, I would say just once you start with just the confidential computing and, the issue of data in use and how to protect it, the other things become simple. It's harder, so easier to understand. Okay, so how you can what is the simplest way of doing it? The simplest way of doing it, there are Azure virtual machines that you can go ahead and launch that supports this that supports basically confidential compute. You can run your program. You may be running them on-prem. You can just bring your program straight onto run those virtual machines. That's the simplest way of doing it without making any code changes. They both support trusted launch to make sure, for example, if somebody has hacked the system and they're trying to do a malicious boot, it will not work. And with the VTM, at the startup time, you can call the destination service to make sure all the requirements, the room is properly checked for any bugs or any kind of infiltration before the security meeting. So that's the goal. So that's what it allows you to do. So I think what I'm going to do is I'm going to just quickly jump into a very short demo to show like how you can do it in Azure as of right now. So first of all, let's go into our resource group. So here we are, we are in a resource group. And what we're going to do is we're going to create a virtual machine. Okay. So I'm going to go in here and I am going to pick a VM. I'm going to pick Ubuntu. Actually, yes. So let's start with a, okay, let's do a create. We're going to go from here and let's pick East US. And this is interesting. This is where you pick. You want to pick confidential virtual machine. Okay. And it's going to say this image does not meet confidential virtual machine. What you're going to do, you are going to go in here and pick what are the system that meet that requirement. So you go in here and you basically security type, that's what you select, confidential, and now it will show you what operating system that are available with support. So you can unselect all, let's select Ubuntu, and it will show you what are the two. You can select that. Oh, sorry, I missed that. You can select this, and that's that. Once you move forward, so that's where it's gonna show you all the images which supports confidential compute. Okay, so that's the important piece. You want to, it cannot run on any hardware. You can just bring in hardware, run it. It has to be special hardware. So that's where you're going to go in and you're going to select those. I mean, you can see all sizes and it will show you, look here. I mean, this is, these are the machine that DC and EC series supports it. The rest of them, they are not supported. So basically, let's say we go into DC and we just pick, DCA, we select it. And with that, you can pick the rest of the stuff. Once you click on it, it will start processing and it will basically create your virtual machine. It takes a few minutes to create it. Since we are short on time, so we are gonna kind of do the kind of what we call the cooking show approach, where we show you how to prepare the dish, and I'm going to show you a prepared dish just to save time. So this is a confidential VM that I have created. It's a Linux VM. And as you can see here, this is the SKU and all that information. And so what we're going to do is we are going to run a simple attestation client. So Microsoft provide a SDK, SDK that you can use to do attestation, to talk to VTPM to get. So there is a very simple sample application. So it's not something that I have written, please. It is all available in the documentation. So um, I'm just using that. And uh, and the reason why most of the time I use stuff directly from the documentation. So if you are watching this session, you can go back and you don't have to kind of rebuild the whole thing or look at some GitHub repo or my GitHub repo or something. You can just go into the documentation and look at it and, kind of just quickly play with that stuff to, basically to repro what I did. So this is the goal. So, okay, coming back. So this is the VM that we have created. And here is, I am connected to that VM and I have downloaded. This is a guest attestation client that I have downloaded, Linux executable. And what I'm going to do is it's a C++ client, which basically uh, built in C++. This client, basically what it does is it's called VTAPM APIs to get the information about the existing hardware, and then it calls the attestation service to make sure that it is meeting the demand. I mean, it meets the confidential compute requirement. That's what it does. So let's run this client. So if I just run this client like this, you will see a true. So yes, it meets the requirement, but we want to see the token. Okay. So this is the token. This is, as you can see here, it's a base 64 encoded token. So, and it's basically a JWT. So I am going to take this and copy it. And I have the JWTIO. I'm going to paste it here. And and that's where it shows you. So this was the URL that it sends to. As you can see, this is the attest.azure.net URL where it sends this request. Secure boot. So the boot was secure. So you can see all the information here. There is some information that kind of more in depth. Some of the which is which we can kind of secure boot validated. That's true. Um, you know, there's some. It's a Linux operating system, so this has all the information that is there that the token returns about this attestation, and you get this JWT token. So that's a very simple way. And that's where your program can decide that it can. So think of it that your program that you want to run in this secure environment first need to check this attestation. First, it needs to make sure that the room is secure. Nobody is kind of have devices that they are trying to listen to you. So everything is secure. So this is the that exercise. And if that is not the case, then your program should exit, because it means that somebody has taken over the control of the machine, or it's not meeting the requirement, or there is something wrong. Okay. Any questions? I know there's a lot of information, um, and security sometimes is not very an easy topic. Go ahead,
There are a couple of questions on the chat.
please. Go ahead.
So yeah, sure. Sometimes customers store keys in plain text through container storage interface from Key Vault. I guess this is a great fit for that, right?
That's right. That's right. Yes, exactly. Oh, absolutely right. I mean, because these are the scenario where you have, I gave the example like you are loading social security data. Okay. So let's say you are loading you're a hospital, you are run some analysis, you are loading people's social security number, their health information to run that program. Now it's in memory. And absolutely that. I mean, let's say somebody take a memory dump. What happens then? So this is to address that, to protect data in use. Absolutely. And yes, I'm not sure about bicep, but I saw ARM template is available. If you look at the documentation, there is an ARM template available that you can take advantage of. So yes.
I think you answered the second question, Naveed, of how to do this through Bicep template. So yeah,
Yeah. So let's talk about, yeah. So secret volume, we are coming to it. Give me 1 second. Um, so let's go back to our um, slide deck, and we have 5 more minutes. So this is the simplest way. But then, and these are the machines that you can use to do that. There is support both from AMD as well as from Intel to provide this capability. But a number of customers, uh, they're using containers. They're not using VMs. So how do they do that? So that's where you have the capability of not only running these confidential VMs as a as node pools. So you can have node pools in AKS that consist of these confidential VM, and you can run these containers on it, or creating these confidential containers in AKS all the way through. So all of these things are available. Just keep in mind that as we go further towards the right, um, yes, you may have to refactor your application, but you get a higher level of security. As you can see here, it can provide security at the line of code. So you can say, okay, this part of the code executed in a separate enclave. I mean, that's a concept where think of it like an isolated enclave where your code is running, nobody can access it. Okay, so uh, that level of control will be available if you go with that particular approach. But once again, it's have more security control, but it's uh, puts some administrative as well as kind of a developer overhead on you. Okay, so you have on the other hand, if you go with the ease of use, where you can just bring, lift and shift your programs, into Azure without making any code changes. Okay. So on that question of secret volume, I have to look into it, that like how it is doing that. I'm not sure if it is related to it. I For a second I thought, but I think it is different. So I I will get back to you on that. I have to look into it if there is any relation. And let's now go. Oh, first of all, any question? We have 2 more minutes. Before we go any further, I have a few more slides. I just want to see if there are any questions.
No more, like no
No
new
more? Okay,
questions, Naveed.
no
We are
question.
good to go. Yep.
Thank you, Ala. Okay, so as I said, support is not just only available in infrastructure as service and containers. We have PaaS services which are supporting that. You have the um, Azure Key Vault HSM. This is a hardware module that is available as a PaaS service that you can use. You know, then you have Azure SQL always encrypted with secure enclaves. So that's another way where you can run your kind of queries and all that inside a secure enclave, so nobody can kind of access those, or any malicious user. So all of these things are available as a part of that. And once again, the same thing. I mean, you are on the left hand side, where you have confidential VM with trusted launch and all, ease of use, lift and shift. If you want to move towards the right hand side, where you have services, PaaS services, containers, there may be some rework required in your application to migrate, but that is worth the effort. Um, and these are some use cases. I know we are kind of right on time. What are some of the use cases? I mean, that's very obvious. You're going to have heavily regulated industries. That's going to be our areas where you have government, you have financial services, you have healthcare, where you absolutely have to protect data. I mean, we know about HIPAA rules. We know financial services are regular. I mean, very heavily one of the heavily regulated industry, and then government, where you want to make sure that you want to kind of to prevent cybercrime and all that, because you know the bad guys are now very sophisticated. You have nation states now acting as bad guys and causing problems. So that those are the key use cases where they will be looking to take advantage of it. But once again, you know this is open to every customer. If you have a customer, or you are a customer who want to take a look at it, know more about it, please take a look and see. And you saw it, how easy it is to create a confidential VM and start playing with this stuff. So with that, sorry, I'm 1 minute over. Please feel free to ask any questions if you have. Otherwise, thank you very much for joining, and hope to see you on another Azure Power Lunch session next week, and have a wonderful weekend. Thank you,
Naveed.
sir. Thank you, Allah. Really appreciate it, man.